All right. So today this will be the second lecture of the chapter sets. Okay. So we have completed till here yesterday, right? So today again we'll see types of sets like which are completely different from what we discussed in the last lecture. Okay. So first we'll start with equal sets. It's very simple. Equal sets are the sets which should contain same elements, right? So what are we saying here? If uh, yeah. So if every element of A is an element of B, then we call them as equal sets. Okay, so nothing difficult, right? So very simple thing. Yeah. So example is 1 to 3 and 3 to 1, right? The order doesn't matter here. Yeah. Now what is important is equivalent sets. Now what are equivalent sets? The sets which have same number of elements in them, right? So that means the sets which have same cardinal number. Yesterday we learned, right? The number of elements present in a set is called its cardinal number, right? So if two finite sets, if they are having equal number of elements in them, then they are called as equivalent sets. This is important. Understood this?
Yes, sir.
All right. Yeah. Next, we have something called universal set. This is the most important thing. You have to understand it very carefully. Okay. So, what is a universal set? Well, universal set is not any fixed set. Okay. It depends on the circumstances or it depends on the given situations. Right. Let's say in the given situation, there are 2 to 3 sets. Now, universal set is a set which contains all the elements of those 2 to 3 sets. It can contain more elements as well. We don't have an issue, right? But it should definitely contain the elements of all the sets that were discussed in that context. Okay. So a set consisting of all possible elements which occur in the discussion is called a universal set, right? So if we are making a discussion regarding those sets, the universal set in which the discussion is being made should contain all the possible elements of all those sets. Okay. Now he can ask you a question like this. Okay. Uh, let's say set A is 1, 2, 3, set B is 2, 4, 5, 6, and set 3 is 1, 3, 5, 7. Then what can be the universal set in this case? Well, in this case, I can consider the universal set a set of natural numbers as well. Okay. So that can also be the universal set. But why do I want to take all the numbers, right? So instead of taking all the natural numbers, I'll consider this as my universal set 1, 2, 3, 4, 5, 6, 7. Now, in the given context, the universal set contains all the possible elements. Yes or no?
Yes, sir.
Yeah.
Yes.
So universal set is not one fixed set, right? It can be many, like, if he's asking you to find universal sets, you can find many possible universal sets for a given number of sets. Okay. But he himself, is giving a universal set, then you have to consider that as a universal set in the given context. Is there any doubt in this?
No, sir.
All
No,
right.
sir.
So next we will move to something called as subset and superset. Again, this is also very important. Now, what is subset? Okay, if every element of A is an element of B. Okay, don't get confused with equal sets. Equal sets, both the elements of both the sets must be the same, right? But here, if every element of A is an element of B, that means in set B there can be more elements, right? So that is 100% possible. But what we are saying, if every element of set A is an element of B, then we call A as the subset of B. Okay, and B we call as the superset of B. Okay. So here I can clearly see that in this given example, A is 1, 2, 3, 4 set containing 1, 2, 3, 4 and B is a set containing all these elements. Now it's very clear that all these elements, all the elements of A are the elements of B. Yes or no?
Yes, sir.
So that's
Yes,
the
sir.
reason we call A as a subset of B, right? And B as a superset of A. So A is a subset of B, right? This is the symbol for subset, right? All right. If A is not a subset of B, then we write A not a subset. We just put that not equal to type of mark, right? We put that mark, right? And B superset of A, right? Again, it's same. Like it would be open towards superset. Whichever is the superset, the opening of this figure, right? The opening of this symbol will be towards that. Now there is something called as proper subset. Okay. Now let's take some example, right? Let's take A as 1, 2, 3, 4. Okay. B as 1, 2, 3, 4. C as 1, 2, 3, 4, 5, and 6. Okay. Now my question is, can I call A as the subset of B? Yes or no?
Yes,
Yep.
sir.
Hmm?
Yes, sir.
Yes, we can call it, because what does the definition says? If every element of A is contained in B, then we call A as the subset of B. So here we can clearly see that every element of A is contained in B, and therefore I can call it as a subset. But if you carefully observe, here both of them are equal as well, right? Both of them are equal as well. Okay. But what about A and C? A is a subset of C, but it is not equal to C. So in this case, we call A as proper subset, right? It is properly a subset. It is not equal, right? So what do we call here? A is a proper subset of C. All right. So did you now are you making the difference between subset and the proper subset?
Yes, sir.
Yes,
Pawan?
sir.
Yeah. Okay.
Sir,
Now here the question asks, write the proper subsets of 1, 2, 3, set containing 1, 2, 3. Okay, I have to write the proper subset. Before we write this, we have to remember one statement. What is that statement? Empty set is a subset of every set. Okay, empty set means the set which does not contain any element. It is obviously a subset of every set, right? So in order to write the elements of the subsets of 1, 2, 3, what I'll write first? The first would be the empty set, right? Then what all the subsets? So I'll form the singleton subsets first, right? So these are sets. Okay, subset is a set. I should not write it as elements. Okay, I have to write them in the curly braces. Okay, then I can write 1 comma 2. 1 comma 3 will be a subset. 2 comma 3 will also be a subset. What about 1 comma 2 comma 3? It will be a subset. But will it be a proper subset?
No, sir.
no, sir.
No,
Improper
right?
subset.
Yeah, because 1, 2,
Yes,
3
sir.
set containing 1, 2, 3 is equal to itself, right? So obviously this can't be
Yes,
a
sir.
proper subset. Only these are the proper subsets. All right. Okay. What about ninth question? What's the answer?
E, sir.
A. Let A equal to 1 to see. In set A, there is a set which is the element of set A. Okay. So the set 3 comma 4 is the element of set A. Okay. So this does not imply that 3 is the element of set A. Is this statement true or false? Tell me guys, is this statement true or
Yes, sir.
false?
False, sir.
False, right? 3 is not the element of set A. What is the element of set A? 3, 4. Set containing 3, 4 elements is the element of the set A. 1 is the element of set A. 2 is the element of A set A. Set containing 3, 4 is the element of set A, and 5 is the element of set A. Okay. Now he is asking which of the following statements is correct. 3, 4 is subset of set A is saying. Set 3, 4 is subset of A. No. Set
No, sir.
containing
False.
3, 4 is element of set A. Right? It's not the subset. Set
Yes.
containing 3, 4 belongs to A. This is correct.
Yes, sir.
Yes, because this is an element of A. Now, set containing set 3, 4 is subset of A. This is also correct.
Yes, sir.
Right? Because it's a subset. 1, 2, 3 is a subset of A. No, because 3 is not an element of A. If 3 is not an element of A, how can set containing 1, 2, 3 be a subset of A? Understood? So, both the options B and C are right answers. Okay? In JEE
Yes, sir.
advanced examination, you'll have questions like this, wherein there will be more than one correct answer. Okay?
Okay.
Yes, sir.
So we are practicing for JEE advanced. Okay? So we will see all the type of questions that will come in that exam. All right. Now let's look at some important results. Every set is a subset of itself. Again, no need to explain. This is a self-explanatory statement. Empty set is a subset of every set. That is also fine. If A is subset of B and B is subset of A, obviously that will happen only when both of them are equal sets. Otherwise, there is no way that it can happen. Empty set is a proper subset of every set except itself. Again, true. Right? Yeah. This is important, right? The two statements, fifth and sixth, are important. The total number of subsets of a finite set containing n elements is 2 to the power n. Okay? This we will learn in permutations and combinations chapter, but as of now, just try to remember it. Okay? So, for example, let's say if a set has 3 elements, then how many subsets I can form? Well, empty set can be the first subset. This can be the singleton subsets, right? Then 1, 2, 1, 3, and then 2, 3, and finally 1, 2, 3. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So total 3 elements. So number of subsets is 2 raised to the power 3. Okay.
Okay.
So similarly, if a set contains n number of elements, then the number of subsets that can be formed is 2 to the power n. All right. Yeah.
Yes, sir.
So this we will again learn in permutations and combinations. I mean the basic proof, like it's simple only, but yeah, we'll once again look at it in permutations and combinations. Now, if total number of subsets is 2 power n, then what about number of proper subsets? It will be clearly 1 less than 2 power n. So it is 2 power n minus 1. Okay, because in proper subsets, what we will do, we will remove the equal set. So we have 2 to the power n minus 1 proper subsets. This is clear?
Yes, sir.
Okay.
Yes, sir.
What about 10th one? Answer?
16 subsets, sir.
16 subsets. Okay, we'll see. First of all, we have to write what set is in roster form. Right, set A is. So A x equal to 4n plus 1, n lies between 2 to 5, including both of them. So A will be 4 2s are 8, 8 plus 1 9, 4 3s are 2. Again, see, there is no need for me to write all the elements. I'll just have to figure out how many elements are there. So n runs from 2 to 5, including both of them. So there will be 2, 3, 4, 5. 4 elements. So set A will contain how many elements? 4 elements. Now, how many number of subsets will be? 2 raised to the power n of A. That is 2 raised to the power 4. That is 16. So, there is no need for me to find the elements of A. I just have to find how many elements will lie in the set A. That's it. Okay?
Yes, sir. Okay, sir.
Yeah.
Okay, sir.
Let A be ABCD and B be ABC. The number of subsets, the number of sets X contained in A but not contained in B. Yeah. How can we find this? That means they should be subsets of A, but they should not be subsets of B. Right? So how will I do it? What can I do? I can simply find the total number of subsets of A and then I'll remove the subsets of B. Why? Because all the elements of B are contained in A. So all the common subsets can be eliminated. Then I'll have the remaining subsets. Understood? So set
Yes,
A,
sir.
for set A, empty set A, B, C and D. Right? Then we have A comma B, A comma C, A comma D. Right? And so on. Right? For B, what will have 5 A, B, C, and then we'll have A comma B, A comma C, and so on,
A,
right?
comma.
So clearly, whatever the subsets of B are there, they will be definitely contained in B, and we don't want that. So what we'll do? We'll consider all the subsets of A, and from those subsets, we will just remove all the subsets of B. Okay. So we know that the number of subsets of A is 2 raised to the power 4, which is 16, and number of subsets of B is 2 raised to the power 3, which is 8. So the difference is 8. So option A is our answer. Understood this?
Yes,
Yes.
sir.
Yeah. Cool. So the number of, okay, two finite sets have m and n number of elements. Okay. The number of subsets of the first set is 212, 112. So 112 more than that of the second set. Okay. So if the first set has m elements, then it will have 2 to the power m subsets. And the second set will have 2 to the power n subsets, and it is given that first set contains 112 more subsets. That means their difference is equal to 112. Understood this equation? How did I form this equation?
Yes.
Yeah.
Yes, sir.
Now how do I do? I'll simply use the options. I'll substitute for values of m and n. I think it's when I substitute m4 and m7 and n4, then I'll get my answer. Okay. So this is how you have to solve this sort of questions. All right. Yeah. Now we are learning something called as power set. Okay, what is a power set? It's simple, right? Let's say there is a set A. Okay, now we have formed all the subsets of that set A. Okay, now we are forming a set containing all those subsets. That is called as power set. Understood?
Yes, sir.
Okay, so
Yes, sir.
there is simply set A. Let's say 1, 2, 3. Okay. First of all, what I have to do? I have to form all the subsets. So 5, 1, 2, 3. Then 1 comma 2, 1 comma 3, 2 comma 3. Then 1 comma 2 comma 3. All the subsets I formed. Now what I'll do? I'll form a set containing all these subsets. This is nothing but my power set of A. Okay. It is a set containing all the subsets of a set. Right. Now my question is, if a set A contains n elements, then how many number of elements are there in its power set? Answer me.
2
2 raised to the power n. That's it, right? Because what is power set? It is the set containing all the subsets of the set A. And we know that if a set A has n number of elements, then the number of subsets will be 2 raised to the power n. Therefore, the number of elements in the power set will also be 2 raised to the power. Got it?
Yes, sir.
Yeah. All right. Let's solve this question. 13th question. The number of subsets of the power set. See, now he's not asking the number of subsets of the set. He's asking the number of subsets of the power set. That means, what do we have to find? First of all, we have to find how many elements are there in the power set. So, if set A contains 3 elements, how many elements are there in the power set?
8, sir.
8 elements, right? Because it is 2 raised to the power 3, which is 8, right? Now we have to calculate how many subsets are there for this power set which contains 8 elements. So how many are power set? How many subsets will be there for a set which contains 8 elements?
8
Sorry?
60.
No, first see. Power set of A contains how many elements? 8 elements. Okay. Now we have to find the number of subsets of this set. So you have to find number of subsets of a set which contains 8 number of elements. What's the answer?
8 and 64, sir.
Why 64? How do you calculate?
Number of sets 8, sir.
Okay. Number of sets,
Power
no.
set
Number of
లో
elements. Number of elements is 8.
number of elements 8, sir.
Yeah.
పవర్ సెట్ లో 8 ఎలిమెంట్స్ ఉన్న
చెప్పు.
పవర్ సెట్ లో 8 ఎలిమెంట్స్ ఉంటే 8 into 8
ఇక్కడ నీకు పవర్ సెట్ అన్నది అంత అవసరం లేదు. ఇప్పుడు నీకు ఇక్కడ పవర్ సెట్, దెర్ ఇస్ నో నీడ్ ఫర్ పవర్ సెట్. పవర్ సెట్ అన్నది కూడా ఒక సెట్, అందులో 8 ఎలిమెంట్స్ ఉన్నాయి. నౌ యు ఆర్ ఆస్క్డ్ టు ఫైండ్ హౌ మెనీ సబ్సెట్స్ ఆర్ దేర్ ఆఫ్ దిస్ సెట్. Okay, tell me one thing. If a set has n elements, how many subsets will it have? How many subsets will it have? Tell me.
2 power n, sir.
2
power n. Okay. Now here what I am saying is, there is this power set and it has 8 elements. Now how many subsets will it have?
2 power 8, sir.
2 power 8. That's it. Which is 256. That's my answer. Understood, Pawan?
ఒకసారి మళ్ళీ చెప్పండి.
Right.
Repeat.
Yeah, I'll repeat it. Carefully also, okay? The number of subsets of the power set of set A. Okay, what is he asking? First, there is set A. Okay, is he asking number of subsets of A? Number of subsets of A గురించి అడుగుతున్నాడా? లేదు. Number of subsets of power set గురించి అడుగుతున్నాడు. రైట్. మనం నెంబర్ ఆఫ్ సబ్సెట్స్ ఆఫ్ పవర్ సెట్ కనుక్కోవాలి అంటే మనం ఫస్ట్ ఏం కనుక్కోవాలి? పవర్ సెట్ లో ఎన్ని ఎలిమెంట్స్ ఉన్నాయో కనుక్కోవాలి. అవునా కదా?
Yes, sir. Yes, sir.
So our aim, we have to find number of elements in the power set.
Power set.
Now how do I find number of elements in the power set? Power set of A.
2.
I know that number of elements in the set A is 3. So therefore, number of elements in the power set of A will be how much? 2 raised to the power 3. Yes, or no?
Sir.
So it is 8.
Yes, sir.
ఇప్పుడు ఏమొచ్చాయి మనకు? నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఇన్ ద పవర్ సెట్ ఆఫ్ ఏ వచ్చింది. ఇప్పుడు ఏమడుగుతున్నాడు? ఇప్పుడు ఇంకా పవర్ సెట్ అన్న డిస్కషన్ అయిపోయింది. ఒక సెట్ ఉంది, అందులో 8 ఎలిమెంట్స్ ఉన్నాయి. ఇప్పుడు ఆ సెట్ యొక్క సబ్సెట్స్ ఎన్ని ఉంటాయని అడుగుతున్నాడు.
Subsets.
So subsets, how
Yes,
do you
sir.
calculate? 2 to the power n. So this set has 8
N.
elements. So the number of subsets is 2 to the power 8, which is 256.
Yes, sir.
Yeah. Understood, Dimpo?
Yes, sir.
Okay, fine. All right, let's solve the final question. So what's the answer for this question?
256, sir.
No, that is fine. 14th question. I'm talking about 14th. So first of all, A is a null set. So how will I represent it? I can represent it as like this or 5. Okay, so it has no element, right? Number of elements in A is 0. Okay, clear till here?
Clear.
Yes, sir.
Now I have to find set B, which is power set of power set of power set of A, 3 times power set. Okay, first of all, I'll find power set of A, right? How many elements it will contain? It will contain only one element. And what is that one element? The empty set. I can write it like this, or I can write it like this. You can also verify this again, right? If set A is containing 0 elements, then power set will contain 2 raised to the power 0. What is 2 raised to the power 0? Tell me
0.
what is. Oi, what is 2 raised to the power 0?
2, sir.
What is 2 raised to the power 0? 2 raised to the power 1 is 2.
2.
2 raised to the power 1 is 2. What is 2 raised to the power 0? Timpu, what is 2 raised to the power 0?
0.
No? Any
Sir, no
number
value.
raised to the power 0 is 1. This is simple thing. You have to remember this. Okay, na Pawan?
Yes, sir.
So,
Yes, sir.
set A లో 0 elements ఉన్నాయి కాబట్టి పవర్ సెట్ ఆఫ్ A లో ఎన్ని elements ఉంటాయి? 2 raised to the power 0, which is 1 element. Okay?
1.
This is how I represent power set of A. Next, I'll have to represent power set of A. ఇప్పుడు పవర్ సెట్ ఆఫ్ A లో ఒక ఎలిమెంట్ ఉంది. కాబట్టి పవర్ సెట్ ఆఫ్ A లో 2 ఎలిమెంట్స్ వస్తాయి. ఎందుకంటే 2 raised to the power 1, 2 ఎలిమెంట్స్ కాబట్టి. ఆ ఎలిమెంట్స్ ఏంటి? ఫస్ట్ నార్మల్ ఎంప్టీ సెట్ ఒకటి వచ్చేస్తుంది. ఓకే, ఇది ఎంప్టీ
1.
సెట్ కాదు, ఇది సెట్ ఆఫ్ ఎంప్టీ సెట్ వస్తుంది. నెక్స్ట్ ఏం వస్తుంది? ఇది వస్తుంది.
Empty set.
ఇది ఎంప్టీ సెట్ యొక్క సెట్. A set containing
Yes,
empty
sir.
set as its element, right? How can I represent it in other way? I can represent it in other way as like this. Okay, clear?
Okay, sir.
Right, next we want P of
P
A.
of A.
Right, so P of A lo 2 elements ఉన్నాయి. So P of A lo 2 raised to the power 2, which is 4 elements వస్తాయి. So what are those 4 elements? Again, first of all, I'll get empty set, right? Then I'll get a set containing both of them, right?
Empty
This
set.
empty set and set containing empty set. Okay, ఈ రెండు ఎలిమెంట్స్.
Yes, sir.
నెక్స్ట్ ఏంటి? నెక్స్ట్ ఏమొస్తుంది? ఈ సెట్ యొక్క సెట్ వస్తుంది. అంటే దట్ మీన్స్ సెట్ కంటైనింగ్ సెట్, దిస్ ఇస్, ఇది ఒకటి వస్తుంది, రైట్?
Yes, sir.
లాస్ట్ ఇంకొక ఎలిమెంట్ ఏమొస్తుంది? ఎంప్టీ సెట్ వచ్చేసి ఇంకొకటి మిస్ అయ్యాం. ఏంటి? ఎంప్టీ సెట్ యొక్క సెట్. దీన్ని కంటైన్ చేసే సెట్ ఒకటి రావాలి కదా. సో అది వచ్చేస్తుంది. సో దీస్ ఆర్ మై 4 subsets. Now we did in the options we have been given all these, right? So first of all, ఇది సబ్సెట్ ఆఫ్ B అన్నాడు. ఇది సబ్సెట్ ఆఫ్ B కాదు, ఇది ఎలిమెంట్ ఆఫ్ B. If I write in that format, so this is this one, and this is a set containing this, right? Then this, and then it, right? So this is not a subset. Okay, next, is this a subset of B? Is this a subset of B? Yes, ఎందుకంటే we have empty set, right? So this is my set B. So set containing empty set will be a subset of B. This is right. What about this? Set containing empty set is a element. ఇక్కడ వచ్చింది కదా, ఇక్కడ వచ్చింది కదా, it is a set containing empty set. So it is an element of set B. So this is also true. And lastly ఏమంటున్నాడు? empty set belongs to B. Correct. ఇక్కడ empty set ఉంది కదా, it belongs to B. So
Yes,
both
sir.
3 options B, C, D are right answers. Understood this question?
Yes, sir.
Right? So this is how you have to do them, like very patiently, step by step you have to do, and you'll get the answers. Any doubts in today's class?
No, sir.
Sir.
All right. So this is the second lecture of sets chapter. We have two more lectures. Right. Okay. Fine, guys. So we have completed our lecture. Just give me a moment.